Thank you all for coming. My name is Michael Weiss-Malik. It's my pleasure to introduce our guest speaker today. Michael Kosowsky is, among other things, the creator of heywhatsthat.com, a unique 2.5-dimensional maps API site that lets people generate mountaintop vistas and explore them. I think that's about it. So without further ado, Michael.
That was really nicely done. Well, thank you. Thanks for having me out here, and thanks for that kind introduction. Actually, you got it better than I've got it in the presentation. A much gentler introduction that a colleague just related to me, where he was introduced with the words, and as you know, Andrew Wiles proved Fermat's last theorem in this auditorium last week. I hope you have an interesting talk planned. I'm Michael Kosowsky. I'm from Lincolnville, Maine. I'm the sole proprietor of Hey What's That. What I'd like to do is simply show you what Hey What's That is, provide some background on how it got here, and speculate a little bit about what's going to happen next. So this is where it began. When we moved into our new house in Maine, I asked the owner, what are those mountains over there? And he responded he thought they were out on Deer Isle. And a couple weeks later, I had a friend over, and we just bought one of these large-scale maps of the state, so we took some bearings, and if anybody's ever tried this, it's extremely difficult to do, particularly if there are a couple of choices. So we're there with the rulers and everything, and we realized he was wrong, but we didn't quite know what was right. And now, several years later, unveiled in the first week of March, I posted about the site on a couple of forums. A week later, I emailed some bloggers, and within 24 hours of the blog post coming out, I got this invitation to speak here. So it's all pretty new, and I'll show you where it started. This statement actually appears on the first post on the Keyhole BBS to answer the eternal question, what am I looking at when standing on a mountaintop or pulled over at a scenic overlook? And that's where I'm going to start, because that was the focus for the site when I released it. So when you first go to the site, and let's do this live, you're greeted by a window with three panes. This is the view from Mount Batty. It's a local summit you can drive to in Camden, Maine. On the top, and again, the focus is on letting you know the names of the mountains you can see. So we've got a computer-generated silhouette along the top. We've got a list of peaks along the side, and a Google map on the lower left-hand side. And I want to thank you all for Google Maps, because otherwise there'd be this big hole in the middle of the screen. And it's all got the kind of interactivity we expect from applications. If you click on a name, it shows you where it is on the silhouette and on the map. You can click on the silhouette, and if you happen to hit a peak, it'll tell you what it is. Otherwise, it'll just give you the sight line along the Google map. And of course, you can click here and either see your azimuth on the top, or if you click on a peak, it'll show you the information. A couple other things about this display. There is an FAQ which tells you how to do everything, and if you go to the FAQ, there's a further technical FAQ. Sign up simply asks for an email address at this point, and the best way to keep apprised of what's going on with the site, I've been sending out an email every 2 or 3 weeks, I think, as things develop. Comments let you email back to me. This view in Google Earth we'll come to in a little while. You can switch back and forth between true and magnetic north, and it updates the bearings. Of course, it doesn't turn the Google map, but it does play a little bit with the, it changes the silhouette from true to magnetic. At least it has in the past. And it should be changing these bearings as well. This arrow, I don't know if anybody ever comes across this. You can change the viewpoint of the panorama. And down here, if you don't like decimal degrees, you can go decimal minutes or degree minute seconds. One thing that I haven't spent much time on is browser compatibility. This will run great under Firefox 2. I'm running here on Firefox 1, which was, I think, some things weren't updating a moment ago. Or this is 1.5. It seems to work pretty well under IE 7. IE 6, I know there are some incompatibilities. I told you the name of the game at the outset, at least, is peak detection. So the way I do that first I take data and then I apply rules to it. The data I use currently is the USGS NASA shuttle radar topography mission data from November 2000, covering 60 degrees north to 54 degrees south. It's a digital elevation model, which means that it gives you the elevation above the surface of the above the geoid at a regular gridded interval. In this case, it's roughly every 30 meters in the United States and every 90 meters outside of it. And you use that data because you basically place yourself somewhere and look over the gridded data and figure out what the silhouette's going to look like. Then I need a geolocation database, just a set of the names of summits together with their latitudes and longitudes. In the United States, we've got the Geographic Names Information Service, another USGS database, which is extremely comprehensive. I believe it's the same stuff they use on the topo map, so that's where it came from. Internationally, I've been using geonames.org, which is a terrific community project. They preload a huge database with the GNIS data for the United States, and then internationally, there's, I guess it was originally military sourced, the NGA data. The problem I run into outside of the United States is that the summit positions will be rounded to the nearest minute often. And we'll see that that's going to cause trouble in a minute. So one of the things I wanted to find out is if there's some better free data out there. Then we apply rules to the data. The first thing I do is draw that silhouette. And then there are 3 rules that I apply. The first is that the peak be visible enough. And the way I do that is go outside, and I was looking, and it looks like you need a couple arc minutes on either side of the peak for it to make the cut. The second thing is that it have a name in the database. Now, detecting the peak, I'm not doing any surface fitting or anything like that, so all the peaks that it comes up with are going to be on grid points. And seldom is a name in the database going to be on a grid point. They come from completely different places. There's no reason that it has to be on exactly the 1 second grid spacing. So I look for a name that's nearby within a certain maximum radius. And this is where the fact that peaks are rounded to the nearest minute outside of the United States runs into trouble, because a minute's a mile, and that's just, I don't want the false positives of allowing a peak to be identified that far away. That, of course, leads to the subsidiary problem of what do you actually display, where you calculate the peak to be, or where whatever gazetteer you're using says the peak should be. If any of you have been watching this site real closely, they've noticed I've waffled on this one a couple times. I spent a week going back and forth. And finally, in a fit of user unfriendliness, I do this. Moody Mountain. This is where the GNIS data says it is. I'm sorry, this is where the peak calculation says there is a peak, and this is where the GNIS data says it is. Of course, I could round. The last decimal place here is about this big. And I think the 4th decimal place would easily, fit in this room. I think this really speaks to having an expert mode of some sort. So if you're interested, you can drill down to get this. All right. The last detection rule is against the horizon. Now this, interestingly, it was originally there to make the computation simpler. And in the top view, which is Mount Batty again, when I was testing this around my neighborhood, the fact that I wasn't picking up the names of stuff, this is all pretty minor stuff. Against the horizon is where the interesting things were. As it was quickly pointed out to me in the first week of March, that's not true for Mount Washington. It turns out some of the most interesting peaks are these down here. This is going to be easy to code around. I'm more worried about simple UI issue of it's really nice having the peaks just along the top. If I have to start throwing red dots in throughout the entire thing, I'm going to have to think about it a little bit more. I've recently heard about prominence, which I guess is one way to rank these things, and maybe we'll just have a sliding scale of the most prominent, and then you can see more and more. My wife's uncle thought I might have to motivate the choice of Mount Washington. For those of us in New England, its majestic 6,286 feet really impresses us, but I understand that that might not be the case when you leave New England, but I'm sticking with it. Just in passing, I'll mention that I do use the World Geodetic System 84 reference ellipsoid, and I correct for refraction. As a practical matter, I do it so that if anybody asks, I can repeat the statement that I just said. One of these is on a spherical Earth. This is all Mount Washington again. One of these is on the reference ellipsoid without refraction, and the last one is on the reference ellipsoid with refraction. Does anyone care to hazard a guess at the order? Refraction is, if you look at a distance, because of the exponential atmosphere, actually at every, there's atmospheric lensing, and there's a rule of thumb, I discussed this in the technical FAQ, that says the surveying rule of thumb is you raise up what you're looking at by amount equal to 14% of its decline due to the curvature of the Earth. Well, you know what's interesting is I'm going to be looking at that. I'm more interested in not just, apparently the lapse rate of the air, it's the rate of change. It's not the actual temperature that's going to do that. And the lapse rate, they say, is fairly constant. What gets interesting is what if there's a front? And that's something that I want to model, and I've borrowed a... That's different, yes, yes. Yeah, there could be a mirage version. But just under general conditions, the question is, how much is it going to change? And people have been telling me, meteorologists, there's a story that I don't even have on here, have been saying it just doesn't change that much. My own calculations show that 14% should be reduced to about 11% when you get up higher. Anyway, but it's a small effect. I think that the point here is that if what you're looking at is the names of peaks, it turns out to be a small effect. What's interesting, oh, I should give the answer. When you go to refraction, because you're raising up things that are more distant, that rule that I have about it being against the horizon means that you lose some peaks because stuff that was flat and beyond it comes up a little bit and the peak is no longer against the horizon. As a practical matter, like I say, it doesn't make much difference. Although, if you printed this out and went to Mount Washington on a clear day, you might be able to tell whether the Earth is spherical or ellipsoidal that morning. There is a print view where I try to get everything on one page. Interestingly, I can't get the Google map to print. I don't know if you guys are aware of that. If you do this, I recommend bringing a compass, because I can only make this work if I have these numbers in conjunction with a compass so the bearings become useful. I'm sorry, if I have the image in conjunction with the bearings. That's the only way I can get it to work. I've got this all panoramas view. And the idea is that you do an interesting search and you can elect to make it public. My notion was to sort of create a community without having to go to the work of policing forums and responding to posts. Of course, the morning after the blog blizzard, I woke up and somebody had made public a search, effing Buffalo. So that threw out the editorial ease of this particular approach. It is interesting to look at what people have decided to make public. But I have two issues with this particular view, and it's probably going to go away. One is just in general UI. This is, I think, only the second version of UI for the whole site, so I'm ready to change it. You know, this should be a cascading menu. Actually, if somebody has a cascading menu for me on the way out, that would be great. I want it to look just like this. Right now I mode switch. So if you go from viewing something in particular to going to all panoramas, it's pretty costly because I throw out all the markers and bring all the new ones. I know that the Google Maps folk have some wonderful dynamic marker stuff now. So I'd like to make it modeless. The back button doesn't work. I'm well aware of that. I don't need anybody else to tell me that. So one issue is UI, and the other issue is editorial. You know, it turns out, other than removing profanity, there are a lot of mistakes in the stuff people make public. Someone just pointed out to me that Kilimanjaro is in at 3 degrees north, and it should be 3 degrees south. You'll see some other examples later on. So somebody's got to do something about that. So this maybe should turn into more of a curated issue. New panorama. The whole point of this is that you can do your own. So let's go back to the live demo. You click on New Panorama. You get the opportunity to enter. We need to get a latitude and longitude from you. You can enter one directly. You can search for an address. You can enter whatever elevation you want it to be taken from. The default is my height, 6 feet. Then there's this move to the highest nearby spot. And what that does, what that is supposed to do is move you along to find the highest point within a certain radius according to the digital elevation model. Again, if you're looking up a latitude and longitude in a gazetteer, it's not necessarily going to match the high point of the digital elevation model I'm using, which means, for instance, that you could be requesting a panorama from a point on the southern slope of a mountain, and your entire northern view would be occluded. You really want it to be up on top. As an example of what can go wrong, I really want to thank whoever did this. When I took a look, this was on the public page as Googleplex. And it turned out I took a look, and it's taken from the middle of Amphitheater Parkway. So I reran it as Googleplex across the street. The nearest high point is at the Shoreline Golf Course, the top of the golf course. I noticed I could see it as I was driving in. Much more informative image. And it also points to that editorial thing I was talking about. I don't know how many visitors have come to the site, looked at Google, and seen this, when I really would have liked them to have seen this. So I'll change that later on.
So those inclusions are buildings?
No, it's just high. It's the front of the golf course. I haven't taken a close look, but we can go outside afterwards and take a look. And it's also, you know, the data is coarse when you're up close.
So that's just data that happens to be.
Yes. Yeah. And you're looking, yeah, you're getting blocked by the rise of the golf course. So you come back to your new panorama, and then you hit submit. And what I do now is I take you back to whatever screen you came from, which doesn't really feel like the right thing to do. What I used to do was leave you in the new panorama, which is certainly not the right thing to do. What I think the right thing to do is, we've got a captive audience here for a minute or two. At least the first time you do a search, you're going to be captive for a minute or two. And we know a location that you're interested in. So the right thing to do is geo-target the visitor. So you could sponsor searches in a state. You could sponsor searches in a region. Maybe it's a thematic thing you want to pay for. And as a Mother's Day special, we've got this. And thank you to my younger daughter for making this work for me. Still on peaks, I've also got a phone system. And I'll briefly show you how this works. It's all in the FAQ.
Welcome to What's That? To skip the instructions, hit the pound key.
At this point, we'll ask for your latitude and longitude. You get the option to move to the highest point in the area. And we accept lots of formats. You can read about it in the FAQ.
The computation will take about 2 minutes.
OK, we know where you are, and you're just sitting there with the phone to your ear. So again, perfect place for an ad.
The computation found
32.
peaks. The bearings are magnetic. For true bearings, add
14 degrees.
Mount
Diablo.
MOUNT space DIABLO 2 degrees 33 miles.
Sumo. Peak.
FUNOL.
Okay. You get the point. You can also do it by email. I've got this nifty short little email address. Please, right now, plain text emails if you're going to try it. All we need is a latitude and longitude. You can check the FAQ. I think an optional P means move to the highest peak. You can instead, alternatively, send an address that I'll geocode. This is what you get back. It's formatted to fit on a smaller screen. If anybody is going to try the voice thing, you can drop me a line, and I can tie your phone number through caller ID to an email address, so you don't have to listen to the voices. Oh, by the way, this is what it was reading. I made sure to use the same site here, the same position. I'm going to get SMS where, interestingly, some of the global interfaces to SMS wasn't working for my local carrier, so I wasn't able to get it working before. But I think now I'll be able to just send it back to SMS. And you see, you get the URL so that you can go back and investigate it when you get back to a machine. All right, so back to this statement. I've been focusing on peaks, but what I learned pretty quickly in those first 2 weeks of March is that peaks really isn't what seemed to be important to people, or isn't what seemed to be important. This is what seemed to be important. If anybody knows how to pronounce, I don't want to mangle his name on the air. OK. There have been a couple bloggers who have been extremely kind to the site, and you saw that in the abstract. But this is really where I am now. To draw as much as possible out of the data, while developing only enough interface to find out if there's a way for the site to support itself. I think that what's generally captured the imagination of people coming to the site has been all the auxiliary functionality that I've implemented to let you drill down and visualize the data that I'm using. My wife jags me that I get into a cycle where I'm stuck in the dark days of bugs and interface development and browser incompatibilities, and suddenly a bright ray of light shines forth, either because of a phone call or a posting, or because there's an area of a code that I'm not involved with that I suddenly have a thought about, and then we got a new piece of functionality that's showing us something completely new about the data. And I've been fortunate that that's happened a couple times on this site. So OK, so you take this drive to visualize the data in new ways, and you temper it with laziness, impatience, and hubris, and this is what you get. So we'll start with contours. I'm a little leery here just because, let's see if we can get contours working. You have to zoom in one level just because of the size of the computation. You zoom in one level, and you can get these contours. As you scroll around, thanks to the marvelous G-tile overlay, it fills in beautifully. You'll have to try it yourselves. Oh, and if I was going to say stay off the site so I can get some good response time, but it looks like I can't use the live site anyway. So G-tile overlay has been phenomenal. I also want to be able to show the names data that I use, the geolocation information. I haven't worked this into the UI yet, but I've got a routine called get names data in the JavaScript of the site. And I love this hack. You know, you can create a bookmark with arbitrary JavaScript in it. So you create this bookmark. You're watching the site. And if you hit this bookmark, it'll run the routine, which looks at the center of the map that's currently being displayed and retrieves all the location data for the square degree of latitude and longitude that the map is looking at. So as you can see here, you get these little plus signs. If you mouse over them, it'll give you the name of that particular peak. You can do things like click on an azimuth here, you get the sight line here, and you can see what these different mountains are that way. This is going to become part of the UI, but if anybody wants to do it now, this is the way you get at it. All right, so I'm saying to myself in one of the revisions of the computation, if I change the way I do it, and if I do it this way, I'm actually going to be able to tell you for an arbitrary point whether a particular whether or not it's visible from to the viewer. I call this a visibility cloak. Harry Potter's been a big part of our family the last couple of years. I have been told repeatedly that, in fact, it has a real name. It's the viewshed. You can play interesting games with it. You know, you can scroll around and see how far. What's the most easterly point you can see from Mount Washington? This fringing is kind of interesting. I think it's actually, I don't know what you call it, quantization error, or aliasing, or round-off error. Here's a better example. But what I find interesting about it is one of the emails I got from somebody pointed out, remember that elevation data has an error bar. So in fact, your visibility cloak is not binary. It's not an on-off thing. It's a probability cloak. And this sort of illustrates that, not intentionally. In fact, some of my most beautiful images have always been bugs in graphics code. All right, now, a quick intro to the integration with Google Earth. And you can certainly all hit the site while this is going on. If you hit either View in Google Earth on the web page or View All in Google Earth on the All Panoramas page, you get some layers loaded into Google Earth. You'll get the visibility cloak. And I'll point out that I actually have to generate two cloaks. The Google Earth uses a plot carré projection, which just means it's linear in latitude and longitude. Google Maps uses a Mercator. There's not much of a difference. At our latitudes here, if you're drawing a 1200 by 1200 pixel image for a square degree, in the middle you have to shift up about 3 pixels between one and the other. In addition to the visibility cloak in Google Earth, I give you this thing called entire visible area. And all I'm doing there, it's a polygon joining all the furthest points along the silhouette. One commentator noted that what it does is it shows you your horizon, which I think is a much more poetic way of saying it. Of course, you can turn on this cloak at the same time as the other cloak. You've got a peak layer. You can turn on that as well. And because of that rule about against the horizon, you'll see all the peaks only appear at the vertices of the polygon. Sort of the proof that this is working is if you position yourself at the viewer and look out, all you should see is red in the visibility cloak. And it works pretty well. I personally have a deuce of a time positioning myself at an exact viewer, so this is the closest I could get. What I like to do is, as you all know, fly around. So here again is from Mount Washington. We're looking at some of the other presidential mounds, and you can see exactly which side is visible from Mount Washington and which isn't. The silhouette is available to you as another overlay. And the silhouette's exaggerated. I don't think I mentioned that. It's exaggerated to fill the space, so you can sort of see what's going on here. This right here, I guess, is this right here. And this over here is maybe that. The point is, it looks like you guys got it right in Google Earth. the intro to this was supposed to be, oh, now I told you could go to the site. Why? I got a lot of mail about the visibility cloak. People asking, what's the load on the server? It seems awfully responsive. What have you got going there? And while I'd love to maintain the illusion that there's something very smart and dynamic going on, there isn't. If we look at briefly at the architecture, the data I've already talked about, I've got a lot of C++ code that I've written in here. A lovely data access layer to draw this stuff out, manipulating coordinates, and then the actual applications, which we'll come to in a minute. But this is the important thing, this cycle right here. A request comes in, either telephone, email, or from a browser. It gets dropped in a queue. We run through the answers, and we just throw the results in a directory. Those results are a text list of the peaks, a PNG for the silhouette, PNGs for all the different cloaks. I just use all of your wonderful overlay mechanisms to then implement the cloaks. This is a good opportunity to thank the world of free software and open source software, ranging from the GNU compiler in Perl to Linux and Debian that I'm running, Asterisk Exum, Apache. OK, so we got all the data. What else can we do with it? The last feature came from a colleague asking if he could get a sense of how clean the line of sight was between an antenna he had and somebody was trying to get to. And the answer was sure. So I also look at this as if you were to walk from this point to this point, what would you have to travel? You can even go across the country if you're willing to wait for it. This is walking from Mount Washington to somewhere in San Francisco. I found this fascinating the first time I saw it. I had no idea what happens as you cross the country. Again, you'll have to wait 20 or 30 seconds for that. And you can, I'll go ahead and just try. I'll show you what one would do if this were working. You come up, you just open the Show Profile window, and then wherever you click, it would draw in that same image that we just saw, which looks something like that. You have the option to put a scale on it. That's fairly new. All right, but in the rule that no good deed goes unpunished, I make this functionality available, and almost immediately I see this post on Delicious. Nice, but according to it, you can see the Appalachians from Pikes Peak, Colorado. It doesn't take into effect the curve of the Earth. Now, I had just spent quite a few hours of my life taking the effect of the curvature of the Earth into account. I had no idea what he was talking about until I thought, oh, well, there it is. He must have run the profile, seen this, and concluded that I wasn't thinking about the curve of the Earth. So a little bit more work, and I am willing to state definitively that you cannot see the Appalachians from Pikes Peak. The Earth does get in the way. Was the profile across the body of water what?
Across the body of water, what do you show?
I think I just got zeros for the data. Let's come back to that. Here's with the curved Earth. I just wanted to show that once I had implemented curved Earth, now I have this wonderful synergy where maybe some of your laptops are working. You can bring up the visibility cloak, and then you can click on different places and actually see why a point is or isn't in the visibility cloak. I'll caution you that this is a straight line, and it doesn't take refraction into account. This particular line drawn here, the calculation does. So things might not jibe perfectly, but it gives you a good feel. So in this case, we see that we're getting by this mountain with a fairly good margin. If we move much closer, things are going to get in the way. Interestingly, Michael's title for this talk was a 2.5 dimensional map hack. And I dropped the 2.5D when I sent him the abstract, first because I didn't know what it meant, but then when I discovered what it meant, I was having trouble justifying it until I came to this slide in the preparation. I realized, yes, I hope, in fact, telling you everything I can about the structure of the Earth on a flat screen, granted in a very analytical style. I don't have textures and polyhedra and monsters pursuing gradients, but I think you were right, so I appreciate that. This post appeared on Google Earth. Does anyone know a way to get plots of elevation versus distance along a Google route? And I was showing that I was sitting with a friend when we read this, and I said, well, yeah, I can certainly do that. And thus the path profiler was born. I'm going to try one more time. This one is really a hack. I refer to the UI as unapologetically anachronistic in an email. Because how many Web 2.0 apps do you know that, or how many apps will call themselves with impunity Web 2.0 apps and Ajax and all the rest and have a button marked backspace? My daughter responded, that's the dorkiest thing she's ever seen, my older daughter. I assume she's talking about the backspace button. She may be referring to the fact that I called it unapologetically anachronistic. I hope it's one of those two. The idea is that you plot points on a route. And thanks to Google Directions, you can even hit this get route. And what it does is it will fill in a smooth path along roads between the last 2 points that you've clicked. You then hit calculate profile. We'll try it. And you get something that looks like this, where it's showing you the different segments and your elevation. Here you have available the flat Earth and curved Earth. I've also given you the option for English and metric. For some reason, the posting about this site got picked up by some Spanish bloggers. And I had all these Spanish sites mentioning the path profiler. I don't speak Spanish, but thanks to Google Translate, I discovered this one comment was this plaintive, well, I guess we'll just have to wait till it can do metric. So the main site doesn't have metric, but this site does. One interesting application is that my wife called running out of gas in rural Maine late at night, which for us means after about 8 p.m. So great, I could get on Google Maps, find her a gas station, but had I had this integrated with Google Maps, not only would I have been able to find her the closest gas station, I could have told her the gas station she could coast to. This is what the profile is actually plotting. You take your start point and your end point. It's the x is the great circle distance as you move along. The y for the flat Earth is simply the elevation above the geoid. For the curved Earth, I add this distance from the chord between start and end. This has some interesting properties, or in fact lacks some interesting properties that I can go into during Q&A. All right, so where are we? I've got a version out. It's been interesting to see what people are interested in. There's clearly lots of different levels of work to do. I've whined about the UI repeatedly. I'd like to get more detail into some of the output that I show, and I discussed ranking the different peaks. In terms of monetizing the site, there are various ways to specialize it. You know, there can be consumer stuff, a hiking site that maybe could draw some high-value ads for hiking, a biking site, coastal boating. There's also business applications, cell towers. You put up a cell tower, you want to know the region it's going to cover. I propose that getting rid of refraction and changing some of the line of sight that I do, I should be able to handle radio frequencies fine. There's the other problem of you put up a cell tower, where's it going to be visible from? In fact, there's a controversy going on in my own hometown right now. So if we were to couple the visibility cloak with information about how far away different designs are visible under different conditions, I think I could have some interesting answers to that question. I want better data for outside of the United States. On the plane, I came up with this game, pin the name on the mountain. The idea is we take Google Maps or Google Earth, create one layer, which is the local maxima of the elevation data, create a second layer, which is that names data, and let people who know an area drag the name over to the peak, funnel all the data back out through geonames.org or something. I mean, summer of code, right? I think that's a good one. I want to do more mobile. I mean, you could certainly build applications into, you can make a phone application available, a GPS application available that would do more than make you listen and scratch down the bearings and names as they came across the telephone. This barcode every mountain is, I got to bring a stack of barcodes with me. So whenever you're on a peak, it's interesting, leave one there, email me where it was, and the next person who comes up with their cell phone can swipe it and get the list of what they can see. Web services, I love input on how to monetize some of this. Either OEM the search, so let's say you owned a chain of coffee shops or something. When somebody searches through your site, they get not only the names of the peaks, but the distances to the closest coffee shops. And certainly the architecture would already let me be a list of peaks, a profile, a contour, or a viewshed server. You'll have to trust me that usually when you hit those buttons, something changes on the screen. I've got to acknowledge Mid-Coast Internet Solutions, who, for their extremely generous co-location service for all of this. Since I know this is being archived, and I don't do talks like this very much, I just want to do two personal acknowledgments, if you'll indulge me. First, just to my family for their support and patience. And then I just want to speak aloud the names of two friends who have been very supportive of this whole process, who are particularly excited about the invitation for the talk, but didn't survive to reach this day. It's my neighbor, Nick Turkovich, and my mother-in-law, Susan Drawbridge. Now, back to the eternal question. Somebody got the, thank you, that I opened with. What are the names of the mountains? I can't do it live. If this is the view from my backyard, you click on that mountain right there. It's Bernard Mountains, 36 miles away in Acadia National Park. Thank you. All right. There was a question about over bodies of water.
Yeah, I thought the profile view would be more interesting and also convey more information if you had a little flat, color distinguished,
Change the color for the water.
And of course, it's correctly flat.
I mean, it should look flat.
You've already made these things light blue, so maybe the color isn't very good.
Yeah, I haven't been coloring this. There's lots of stuff you could do with the profile. And one thing I'd like to do is make it interactive with everything else, so you can actually figure out where you are on the profile.
Looking at this, it's just my personal orientation, but were you ever tempted to make an image panorama to accompany this diagram panorama?
Interesting question. I actually spoke to a gentleman, how much time do I have? Yeah, let me tell this story, because this is a pretty good one. One of the first posts in response to my initial post was this. Your view from Mount Washington fails to show Mount Katahdin, which I recall to be very visible from the summit of Washington. So my first response, I hem and haw about refraction. You know, it might have more effect than I think. I'm driving my younger daughter down to our high school team was in this basketball, the state championships. Go to a bookstore afterwards, and there's this book called Scudder's White Mountain Viewing Guide, where this gentleman, Brent Scudder, climbed 50 different peaks. He's a retired meteorologist, took photos, projected them up on his wall, made a slide of azimuth bearings, projected that up, took the data, covered his barn floor with topo maps, and drew pictures like this for all of them. So I talked to him. I mean, I opened it at page 220. Katahdin has never been visible from here. So I gave him a call on the phone, and I asked him that very question. Why isn't your book pictures? And he said one problem he had was as he takes pictures, keeping the horizon in the same place. Okay, that can be overcome. The second is to get the full 360 degrees, sometimes he has to move because there's an obstruction. So having a seamless photo was a problem. And the third point he made, and I've heard this about bird books also, you can tell people a lot more in a diagram because it doesn't have a lot of extraneous stuff, like the particular weather conditions that day or occlusions. Here you can specify exactly what you want somebody to see. I'm not against the idea, but...
This is what I'd like to see, the picture and the diagram, not the diagram without the picture. That's all. It's if they're on the cover.
Oh, yeah, but that's the only one he has in the whole book.
I understand.
Yeah.
I wasn't talking about a literal panorama constructed by someone climbing to the top of the mountain and taking a bunch of photographs. I was talking about creating a panorama from Google Earth.
From Google Earth, did you say?
Finish the tiles.
Oh. Okay. No, I haven't thought about that. That's a great idea.
To get really fancy, of course, you can have a little slider of transparency.
Make them bluer.
Yeah.
Now, when I fetch the tiles, I don't have any control over the exaggeration, do I? There's it looks like 1, 2, 4, 8 or something.
Well, I don't think you want to exaggerate it.
I'm just saying, but that is the case. I wouldn't be able to. I agree that for some views you don't. But isn't there a little choice for, does that happen afterwards in Google Earth?
They're talking about fetching
Vertical and
flat tiles, I think, and taking services, not fetching a screenshot first.
So if you know what pixels are visible from straight down, that if that particular part of ground is visible in your view shed, you just paint that projection.
I'm going to have to ask you guys afterwards because I'm not following enough, and I think we need the whiteboard.
It'll be a lot more complicated than what makes out.
The rest of that story is that he suggested I call Mount Washington. So I called them, and they said, no, you can't see Katahdin. I wrote the curved earth code. No, you can't see Katahdin. There's too much stuff that gets in the way. And this was the lovely post I got back. Thank you for your diligence in tracking it down. Now, this was a week of my life, but it turned out that, there was somebody up there who said, it's Katahdin. That happens frighteningly often. Same thing with Mount Rainier. It missed the big one. The first place I looked was Queen Anne Hill in Seattle, which is famous for its view of Mount Rainier. So I thought, well, I know that he's going to be wrong. This is great. And then I searched for Queen Anne Hill, and I can't say you can't see it. That turned out to be a fairly interesting bug. Part of it was the data. You can see this thing right here. That went away when I moved to SRTM version 2. Then there was a little bug in the way I did things. It points to a semantic issue, which is that when people think of mountains, they think of these massive things. When I think of mountains, I think of the latitude and longitude of a peak. So in fact, what you're seeing here is Liberty Cap, because it occludes the specific peak known as Mount Rainier, but I had to do some fudging so that, because we all call this, or apparently he calls it, Mount Rainier.
Trees been a
Nobody's complained, but obviously buildings and trees. And when I was talking about cell towers, it occurred to me that one issue would be rural cell towers.
In particular, SRTM, I don't know if it picks up the tops of the trees, or grounds, or if you've got a pretty tall forest.
Yeah, I think that would be, as soon as you get out at all, that stuff's going to get lost in the noise. Any other questions? All right. Thanks.